Number 105, describe the molecular structure around the indicated atom or atoms. And then we have the central oxygen atom in the ozone molecule, which is O3. Okay, the ozone, O3, protective layer for our Earth. But yeah, let's find out the molecular structure of that central oxygen. Now, if they're finding out, or if they're asking us to find out the molecular structure, another word for this is to find the molecular geometry. And molecular structure, molecular geometry, this all comes from a Lewis structure. So the easiest thing to do is to just take a couple of seconds and just draw out your molecule O3. I promise you that if you see it right in front of you, it will be way easier to find out the molecular structure. And as you get better and better with drawing your Lewis structures and noticing the patterns, you can basically draw the O3 in your mind, and then you can find the molecular structure from there. But I have everything written out for you guys. We have this huge chart here. That's all of the molecular geometries that you might see in your class. Your teacher or professor, they may want you to memorize it. I know mine did growing up. So yeah, but your teacher, professor, they may be nice. You know, they may give it to you, but just ask them. So without further ado, let's first draw the Lewis structure. Now there's tons of videos on this channel just designated to drawing the Lewis structure, and we go step by step to find those out. So if you want more guidance, I'm always there every step of the way for you guys on those videos. This one will kind of be like a quick inversion. You could pause the video and see if your Lewis structure matches mine. Now we just have 3 oxygens, and they're all in a line because we want a center one. So there's got to be a central oxygen surrounded by the other 2 oxygens. So we have O, O, O. O, O, O. Okay. So now, everybody has at least a single bond. So we'll draw that. And now we just have to make the Lewis structure work. And one of them is going to have a double bond, because keep in mind that oxygen has 6 valence electrons. So if this oxygen uses 1, 2, that means that it's got 4 remaining. And now this one has an octet. Now, for the other oxygen, if we do put a double bond for this one, this oxygen is going to have its octet already, 2, 4, 6, 8. And we know that oxygen should have some lone pairs. Oxygen will never have just 4 bonds. That is like very, 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 very rare, very unstable. So we're going to strip this one away, and we're going to give this oxygen 1, 2, 3, 4, 5, 6. And then this oxygen has the 3 bonds, so it just needs 1 lone pair. And this should work. This is the Lewis structure. Doesn't matter whether you put the double bond on the left or you put the double bond on the right. Absolutely not. Those are called resonance structures. So ozone has a resonance structure. And as a side note, the more resonance structures you have, the more different ways of drawing a compound, the more stable the compound is. And that's why ozone is a protective layer for the Earth, because it's a super, it's a stable molecule. Now, the next thing is, there are secret formal charges here. If you guys want to try out your calculations of formal charges. Do we need formal charges here to find the molecular structure? Absolutely not, but I am a stickler. So I just like to make sure everything is on the table, per se, when we're doing these questions. So can you find the formal charges for these oxygens? There is a +1 charge for the middle oxygen, and a -1 charge for this oxygen that I drew, making the whole molecule neutral, because a plus cancels out with a minus. Okay, now we want to find that central oxygen atom, right? The molecular geometry. So this is the one that we want. So in this case, there are 2 things that we have to take into consideration: the number of atoms around that atom and the number of lone pairs that are around that atom. So for the center oxygen, and that's the one they wanted, the center one, how many atoms are around that oxygen? Well, the 2 oxygens. they're both bound to the center one. So they both, come into play. So we have 2 atoms. And now we want to search for the lone pairs. And this oxygen has 1 lone pair. Notice how we don't care about these because they're not bound to the center atom. Now, we just want to see what category we're in. So we just add the 2 of them together. 2 plus 1 is a total of 3. So I'm looking for the 3 land, which is right here. Now, there's 2 options, whether you're trigonoplanar or whether you're bent or angular. Me personally, I've never heard of a teacher or professor say angular. Generally, the word is always bent. So if it is this one, we're going to go with bent. And this has to do with the lone pairs. And we said that this had 1 lone pair, so we're over here. So it is bent because you just find where they meet up. So this would be bent. Bond angles are a little bit less than 120, mainly because when you start adding lone pairs, they want to be the maximum away from the bonds. So the bonds get kind of like squished together. But that's it. That's the answer to this question. What do you think? I hope this helped. Let me know in the comments. Subscribe to the channel if you want to help us out. Thank you. Thank you. Thank you. Thank you for being part of the community. Thank you for coming here to get your educational needs. For chem, we also got physics and math videos on the channel thus far, with more subjects coming your way. We really want to see you guys improve in your schooling. So, yeah, keep working hard, and I'll talk to you soon. Bye-bye.